So we have 20.8%
oxygen in the room.
Oh,
So
that's perfect. Those are perfect values. Yeah.
Can
you then measure the oxygen concentration here in the room?
I do already have one set up that measures the content in this room. We can go over to that one.
Let's move it over. I'm just make some space here. Yeah. Okay. Let's see. I hope we can see this. If we look into the system.
So
yeah. So what do we have here?
Now we have the OxyIQ.
Yeah, we have the same
galvanic fuel cell analyzer. We have
there.
integrated it into a sample conditioning system. Yes. Sample conditioning system, very important.
This is a sample conditioning.
You can see here, we are displaying the oxygen here,
yes.
20.8.
So we have 20.8%
oxygen in the room.
So that's perfect. Those are perfect values. Yeah.
20.9. So a little bit. I think we should open the window to get some more fresh oxygen here. But I think still in the allowed ranges.
Okay.
Why we need to have this?
Yes.
We need to condition the samples to the technology, to the measurement.
Yes.
The sample, the process gas, might have high pressure, right? But the high pressure is not good for the fuel cell. Yeah. We need to reduce it to allowed levels.
The fuel cell at the bottom of this.
It's here inside.
Exactly.
It's here inside.
Okay, so it needs to be reduced. Where's the gas coming in? Then?
From this side. That's the sample inlet. So and then we have the 3-valve here. That's open.
Yeah.
Then we have the pressure regulator. We regulate with that. Before we start, the first thing we close this one.
Yeah. Okay.
Then we regulate the pressure, look at the pressure gauge, so that the pressure is the maximum set here.
Yeah, okay.
400 psi-G or 27.5 bar-G. That's like overpressure, I would say.
Okay.
And then after we open, we adjust the pressure here.
Yeah.
That's the second door we need to open, so to say. That's the needle valve.
Yeah.
When we open this needle valve, we look at the flow meter that the flow rate is about 30 liter per hour.
Yeah.
This is a standard liter per hour, and this is the standard cubic feet per hour.
Oh, okay.
And another item that we have is this filtering particle filter that is filtering particles out if they are
there
present.
needs to be a filter before the so as not to destroy the...
Exactly. So this is like a plug and play that you can just put in and turn it on.
So you actually connect the two ends of the gas
basically
there, and then you can work with this directly in your plant. Okay. Oh, very interesting. So this whole setup is needed to make this work properly.
Especially, I mean, we don't know what the process gas conditions are. If we have 10 bar, we need to put them down to what the technology requires. Okay. The same setup we will have for this device and also for the binary gas analyzer. Okay. Because all the technologies, they have certain requirements. And we talk about continuous measurement. So
okay. And you have this in a box. Why is this in a box?
Stainless steel box, intrinsically safe.
So this
environmental protection.
Environmental protection. Okay. Yeah. And this can
because this kind of system solutions are not used just only in the electrolyzer space. It can be used also in the nitrogen, in the natural gas space, where we're blending, for an example, with the hydrogen.
Okay.
So.
Wow, this is interesting.